Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at this question. Question 2, paper 2, Stats Normally, paper 2, 2013. So the heights of a certain type of plant, when ready to harvest, are known to be normally distributed with a mean of mu. Okay, you can see it on the diagram here. It's the typical bell shape we would have expected, and mu is the value in the middle. A company tests the effects of 3 different growth hormones on this type of plant. The 3 hormones were used on a different large sample of the crop. After applying each hormone, it was found that the heights of the plants in the samples were still normally distributed at harvest time. The diagrams A, B, and C on the next page show the expected distribution of the heights of the plants at harvest time without the use of the hormones. So this is A, this is B, this is C, okay? So that's before the hormones. The effect of plant growth of each of the hormones is described on the next page. Sketch onto the diagram a new distribution to show the effect of the hormone, okay? So I suppose the number of plants is going to stay the same. So if you think about this as a histogram, I'm not going to invent or take away any of the plants under it, such as this. If you can imagine the histogram that goes on underneath this, and my drawing isn't great, but just to give you a feel. So in other words, if I make these 2 bigger, I have to remove those plants from somewhere else, and so on and so forth, okay? Just so that I keep the frequency or the number of plants the same. Okay, so let's have a look at hormone A. The effect of hormone A was to increase the height of all of the plants. Okay, now the temptation here might be to increase the graph that way, okay? Because we're used of something like height being on the y-axis, okay? But no, not in this case, because when it's a histogram, when it's a normal distribution, that's frequency. So that's the amount. So if you do that, you're increasing the amount of plants who have this value that mu has. Okay, so if you're going to increase the height of all plants, mu is the height of the plants, then you're going to have a bigger mu. Okay, so you're going to have a bigger mean if you increase the height of it. Okay, so what will that do? Well, it'll just have the effect, and if anybody knows me, they know I can't draw. It'll just have the effect of shifting that curve by a uniform amount is what I would like, but it hasn't happened, by a uniform amount up. Okay, so try and keep the width the same all the way up. And that is the effect of increasing the height of all plants. Let me see if this one works any better. No. Okay, we leave it alone. Okay, something like that. Okay, so basically what you're saying is the mean has increased, mean being the mean height. Okay, so hormone B. The effect of hormone B was to reduce the number of really small plants. So that would be here. This would be really tall. And then everything else in between. So it was to reduce the number of really small plants and the number of really tall plants. The mean was unchanged. Okay, so we're going to have less small, less tall. Okay, so we're going to have a narrower curve. The mean is unchanged, but I still have to account for all of the plants. So although the curve moves in, the mean has to increase because I have more plants, okay? So something like that. Okay, so you can see less small plants, less tall plants, but that'll mean that there's more in the center, okay? And perfectly okay if you kind of centered this a bit around like that, rather than the peak that I have on it. But what you do need to have is less here, and more here. Okay, and then hormone C, the effect on him was to increase the number of small plants, so more small plants. and the number of tall plants, and again the mean is unchanged. Okay, so I'm going to have more of these, so that's going to be higher. I'm going to have more of these. Let me just change color that it's something different. More of these, more of these. So if I have more out there, then I must have less in here in the middle. Okay, but you can see I still have my mean in the middle, so the value that occurs most often is still sitting in the middle. Okay, and that was the effect of hormone C. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.